Hello. Hello students. Today we are going to look into problems of semiconductor electronics. The forbidden energy gap of a germanium semiconductor is 0.75 electron volt. The minimum thermal energy of electrons reaching the conduction band from the valency band should be. If this is conduction energy band, this is valency energy band, and the forbidden energy gap is 0.75 electron volt. So this should be the minimum energy required so that electron from here to here can be there. So out of 4 options, the correct answer is option 2. So answer 2, option 2 is the correct answer. The energy of a photon of sodium light lambda equal to 5890 angstrom equals the band gap of a semiconductor. The minimum energy required to create an electron hole pair is. Minimum energy required is Hc upon lambda, because this is band gap. Hc is 12,400 electron volt angstrom, and this is 5890 angstrom. This is approximately 2. Okay. So the correct answer is 2.1 electron volt. Out of 4 choice, the correct choice is option 3. Option 3 is the correct choice. The forbidden energy band gap in conductors, semiconductors and insulators are Eg1, Eg2 and Eg3 respectively. The relation among them is, we know that in case of conductors, valency energy band and conduction energy band remains in overlap position, while in case of semiconductor, conduction energy band and valency energy band remains at a separation of approximately 0.1, at a separation of 1 electron volt. And in case of insulators, this is more than 6 electron volt. This is conductor, this is semiconductor, and this is insulator. Okay. So Eg3 is greater than Eg2, is greater than Eg1. Okay. Out of 4 choice, the correct choice is option 2. Option 2 is the correct answer. In a semiconducting material, the mobilities of electrons and holes are mu and mu h respectively. Which of the following is true? Since electron remains in conduction energy band and holes remains in valence energy band, so mobility of electron remains more than mobility of holes. So mu is greater than mu h. So out of 4 choice, the correct answer is option 1. Option 1 is the correct answer. A potential difference of 2 volt is applied between the opposite faces of a germanium crystal plate of area 1 centimeter square and thickness 0.5 millimeter. If the concentrations of electron in germanium is 2 into 10 power 9 per cubic meter and the mobilities of electrons and holes are 0.36 and 0.14 meter cube upon volt second respectively, the current flowing through the plate will be. Dear students, since mobility of electron and hole is approximately same, so we can assume the crystal to be intrinsic, okay? And the formula for current in intrinsic is NIEA What is VD? VD upon E equal to mu. So VD equal to E into mu. So this is NIE mu E plus mu H. Okay, into E is V upon L into A. So we will apply this formula and solve the question, okay? So dear student, in this question, what is Ni? This is 2 into 10 power 19. Electronic charge is 1.6 into 10 power minus 19. Cross section area is 1 centimeter square, that is 10 power minus 4 meter square. What is mu E plus mu H? Mu equal to 0.36 and mu H equal to 0.14, so 0.6, okay? So after solve into V upon L, V is 2 and 0.5 millimeter. After solving this, we will get this relation 10 power 19 and 10 power minus 19. This will get cancelled. This is 10 power, this is 2, 3.2 into 10 power minus 4 into 2 into 0.6 upon 5 into 10 power minus 4. So power 10 power minus 4 will get cancelled. So this is 3.2, this is 1.2. 3.2 into 1.2 upon 5. After solving this, we will get approximately 24, 36, 38. This is 3.84 upon 5. So approximately 0.60, okay. Answer is 0.64 ampere. So out of 4 choice, the correct choice is option 4. Dear student, option 4 is the correct answer. A potential barrier of 0.5 volt exists across a PN junction. The depletion region is 5 into 10 power minus 7 meter wide. The intensity of electric field in this region is electric field equal to potential barrier divided by separation depletion layer 5 into 10 power minus 7. So this is 0.1 into 10 power 7. So 10 power 6 volt upon meter. So out of 4 choice, the correct choice is option 1. So we will take option 1 as correct answer. A semiconductor X is made by doping a germanium crystal with arsenic, means pentavalent impurity. A second semiconductor Y is made by doping germanium with indium, means trivalent impurity. If two are joined end to end and connected to a battery as shown, which of the following statement is correct? In this question, this is N-type semiconductor and this is P-type semiconductor. When N-type semiconductor is connected to the positive terminal and P-type is connected to the negative terminal, this becomes reverse bias, okay? So X is N-type and Y is P-type and the junction is reverse bias, okay? So out of 4 choice, the correct choice is option 4. In the given figure, which of the diodes are forward biased? This is very good question for Neet and JEE. In case of forward biasing, the P part should be in positive, okay, with respect to N part. So here in the first diagram, here P is 0 and N is plus. So this is reverse bias. In the second diagram, P is plus 10 and N is plus 5. So this is comparatively plus 5, okay. So this is forward bias. And here P is minus 10 and N is 0. So this is also reverse bias. Here P is -5, N is -12. In comparison to this, P will be at +7. So this is also forward bias. Here P is 0 and N is -10. So in comparison to N, this is at +10. Okay, so this is also forward bias. So 2, 4 and 5. 2, 4 and 5 are forward bias. So out of 4 choice, the correct choice is option 2. For the given circuit of PN junction diode, which of the following statement is correct? Since this is a forward biasing, because P part is connected to the positive terminal. In case of forward biasing, the diode will act as a 0 voltage drop. Okay, in forward biasing, the voltage across R will be V volt. Okay, so out of 4 choice, the correct choice is option 1. Current in the circuit will be, this is direct formula. See, this is positive terminal, so this diode is in forward bias, and this is positive terminal. This is connected to negative. This diode is in reverse bias. So this will not conduct and this will conduct. Okay, this will act as a 0 resistance. So current in this circuit will be how much? Potential difference upon resistance. This is 50. So 5 upon 50. Okay, out of 4 options, the correct answer is option 2. The diode used in the circuit shown in the figure has a constant voltage drop of 0.5 volt at all currents and a maximum power rating of 100 milliwatt. What should be the value of resistor R connected in series with the diode for obtaining the maximum current? For obtaining current for maximum power rating, the voltage drop at diode should be 0.5 volt. Okay. Since power rating is 100 milliwatt, milli means 10 power minus 3. So I square into R, I into V. V into I. This is the current. So this is 0.1 upon 0.5. This is 1 upon 5 means 0.2 ampere. Current should pass. Okay. For passing 0.2 ampere current, what is general equation? Current equal to net EMF 1.5 minus 0.5 means 1 upon resistance. So R equal to 1 upon 0.2 means 10 upon 2. This is 5 ohm. So out of 4 choice, the correct answer is option 2. Option 2 is the correct answer. This is very good question. In the following circuit, PN junction diodes D1, D2 and D3 are ideal for the following potential of A and B. The correct increasing order of resistance between A and B will be. Just we have to see which diode is in forward bias. If diode is in forward bias, it will act as a 0 resistance. If diode is in reverse bias, it will act as a infinite resistance. Okay. Now let's compare the voltage. In the part 1, A is at minus 10 volt and B is at minus 5 volt. So for A circuit, A is minus 10 means diode D1, reverse bias D3, reverse bias and D2, forward bias. So this will conduct. If this will conduct R by 4, R and R by 4. So resistance will be 3R by 2 between A and B. And in case part second, this was for part 1. For part second, minus 5 volt, minus 10 volt means A is at high potential. If A is at high potential, D1 forward bias, D3 forward bias and D2 reverse bias. So R and R will become R by 2, R by 4, R by 4. So total distance will be R. Okay. In case of third, minus 4 volt, minus 12 volt means again A will be at high potential. So same will be the situation. This will be R. Okay. So second, third, resistance will be lesser than first one. Okay. So out of 4 choice, the correct choice is option 3. Option 3 is the correct answer for our question. Which is the correct diagram of a half-wave rectifier? The purpose of half-wave rectifier is to use step-down transfer to convert AC into DC. So, and the C is used as a filter circuit. So, out of 4 choice, the correct choice is option 2. The output current versus time curve for of a rectifier is shown in the figure. The average value of the input current in this case is average value of input current in this case. Input current remains equal to 0. Input current remains 0. And average value of output current will be equal to 2I 0.5. So out of 4 choice, the correct answer is option 1. A full wave rectified circuit along with the input and output voltage is shown in the figure. In this diagram, diode 2, which diode 2 will be B part and D part. So option 2 is the correct answer. For the first half part of input AC signal, diode 1 will conduct, and for the second half part of input AC signal, diode 2 will conduct, and this is centrally tapped transfer which will maintain phase difference of pi. So correct choice is option 2. Option 2 is converted by AC into DC by diode 2. Okay. The combination of NAND gates shown here under the figure are equivalent to. This is very good question now. This is A. So this will become A bar. This will become B bar. And A bar dot B bar bar means this will become A bar bar plus from D Weber theorem. So this will become OR gate. And here this is A dot B bar. This is A dot B bar. And this is A dot B bar bar. A and A is same. So this is A bar bar means A. This is AND gate. Okay. So out of 4 choice, the correct choice is option 1. Given below are 4 logic gate symbol figure. Those are OR, NOR and NAND gate. So which is OR gate? A is the OR gate. And which is NOR gate? This is NOR gate. And NAND gate, this is NAND gate. So A, C and D. Out of 4 choice, the correct answer is option 3. Option 3 is the correct answer. Which of the following gate will have an output of 1? See, this is 0, this is 1. So 0 plus 1 bar. 1 bar means 0. This is 1.0, this is 0. This is 0 dot 1 bar. This is 0 bar, this is 1. So this is the answer. So option 3 is the correct answer. Which logic gate is represented by the following combination of logic gates? This is A bar, this is B bar, this is A bar plus B bar bar. This is A bar bar dot B bar bar. This is A dot B. So this is AND gate. So out of 4 choice, the correct choice is option 3. This symbol represents here A and B are clubbed. So A dot B bar, this will become A bar, not gate. Out of 4 choice, the correct answer is option 1. In an NPN transistor, the value of base current is 100 microampere, collector current is 9 milliampere. Then emitter current will be C, emitter current equal to base current plus collector current. So this is 100 microampere means 0.1 milliampere plus 9 milliampere. So correct choice is 9.1 milliampere. Out of 4 choice, the correct answer is option 1. Option 1 is the correct answer.